Storing a value at some key can have one of few different effects on the map. If an entry with a key does not exist in the map, then a new key value entry is added to the map. If an entry does exist, then the existing entry's value is updated to the new value. If the new value is the same as the existing value, then the entry does not change. For instance, consider the map VA Virginia and OR Oregon. Suppose that we want to store Texas at key TX. First, we pop and inspect the map entries one by one to see if an entry with key TX already exists. We push the inspected entries to the processed map. Here's a table that shows this process. The map is initially VA Virginia and OR Oregon. The top entry is VA Virginia. The key is not TX, so we popped the top entry and push it to the processed map. Now the top entry is OR Oregon. The key is still not TX, so we pop this entry and push it to the processed map. Now the original map is empty. TX was not found, so we create a new entry called TX:Texas and push it to the original map. Then we dump the processed map back into the original map. The result of this process is the map VA Virginia, OR Oregon, and TX Texas. Notice that the dump process preserved the order of the existing entries. Here is a video demonstration. Next, let's store Orlando at key OR. When we see an entry with key OR, we replace the value with Orlando and dump the processed map back into the original map. Here again is the tabular view. Initially, we have entries VA Virginia, OR Oregon, and TX Texas. The top entry's key is not OR, so we pop and push the entry to the processed map. Now the top entry is OR Oregon. The key is OR, so we have found our key. We're going to replace Oregon with Orlando. Now that the value has been updated, we're going to dump the processed map back into the original map. Here is a video demonstration. Let's now try to precisely describe the store operation. We need to keep track of the processed entries, so we first convert the store operation to the store compute function, whose inputs are the map, key, value, and processed entries. Here's the conversion property. The result of storing value at key in map entries is equal to the output of the function store compute, where input key is the same key, value is the same value, map is still entries, and the processed map is an empty map. We can describe the behavior of the store compute function in three properties. Property 1 says that if the entry key is not equal to the new key, then the output of the function store compute, where input key is new key, value is new value, and map is entry key, entry value, and remaining, and processed map is KVS, is equal to the output of the function store compute, where input key is still new key, value is still new value, map is remaining, and the processed map is entry key, entry value, and KVS. Property 2 says that if entry key is equal to the new key, then the output of the function store compute, where input key is new key, value is new value, and map is entry key, entry value remaining, and processed map is KVS, is equal to the result of dumping KVS to key value remaining. Property 3 says that the output of the function store compute, where input key is key, value is value, and map is empty, and processed map is KVS, is equal to the result of dumping KVS to the map key value. Property 1 says that if the current entry key is not equal to the new key, then move the current entry to the processed map. Properties 2 and 3 say that if the current entry key is equal to the new key, or the original map is empty, then push the new key value entry to the original map, then dump the processed map to the original map. Let's use the properties to evaluate the result of storing New York at key NY in map entry MT Montana, entry ME main. First, we use the conversion properties to claim that the above expression is equal to the output of function store compute, where input key is NY, value is New York, map is MT Montana, ME main, and the processed map is empty. Since MT is not NY, we can use property 1 to claim that the above is equal to the output of function store compute, where input key is still NY, value is New York, map is ME main, and the processed map is MT Montana. Notice how we move the entry MT Montana to the processed map. Since ME is also not NY, we can use property 1 to claim that the above is equal to the output of function store compute, where input key is NY, value is New York, map is now empty, and the processed map is ME main and MT Montana. The map is now empty, so we can use property 3 to claim that the above is equal to the result of dumping the map ME main MT Montana to map NY New York. This is equal to the map MT Montana ME main NY New York. We can use the transitive property a few times and conclude that the result of storing New York at key NY in map MT Montana ME main is equal to the map MT Montana ME main NY New York.